So welcome to everybody. Thank you for joining us. What we're doing in today's lesson, we're going to have a quick review of what we did last time. And then the main part of today, multiplication and division. We're going to be thinking about multiplying and dividing by powers of 10. And then we're going to go on to the main bit, which is written methods for multiplying and written methods for division. Okay. I know this sounds fairly basic, but this is stuff that I continue to have to teach up to year 10, year 11, especially the written methods for multiplication. So we need to be able to do stuff like a 3-digit decimal number times a 2-digit decimal number. All right, but we'll see when we get there. Let's just start thinking about the review of the previous lesson. Last week we talked about something called BODMAS. Okay, BODMAS, if you remember, just gives us the order that we have to do operations in. So if we had something like that, can anyone remember what it is that we need to do first here? Yeah, well done. Well done, brilliant. We need to do the multiplication first because the M in the word BODMAS comes before A for adding. Okay, the M comes before the A, so multiplying comes before adding. So you do 3 times 2, which is 6. The question ends up as 5 plus 6, so we end up with 11. Okay, so it's important that we remember that. If I change the question slightly, if I put brackets around the 5 plus 3, what would I do first this time? Yeah, that's it. We've got to do the brackets first because BODMAS starts with a B. It means that brackets should always come first, so long as you can work out what's in the bracket. And in this case, obviously, we can because 5 plus 3 is 8. So this time it just becomes 8 times 2. Okay, so it's important that we do remember the order of operations. Where it comes in higher level work is this kind of question which fools people sometimes. So let's see if you can work this one out. If x equals 3, what is the value of 2x squared? Okay, I'll write the x a bit better. Can you have a think about that, guys? See if you can come up with an answer. What we want is the value of 2x squared when x is equal to 3. When we do this question, we normally get 2 answers. only one of them's right. The answer that some people give is 36. In fact, did any of you guys get 36? Yeah. The other answer we get is 18. And did anyone get 18? Yeah, good. Okay, because actually 18 is the right answer. The reason that 36 is wrong and 18 is right is BODMAS. Okay, because if you think about, we'll write BODMAS again. BODMAS. There we go. What's going on with 2x squared is 2x squared basically means 2 times x squared. All right, so you've got multiplication going on here, but you've also got a power going on. X is raised to the power of 2, and that is what we call order. Okay, the O stands for order or powers. And because that comes before multiplying, we have to do the powers first. So it reminds us that what we've got to do with 2x squared is we've got to do the x squared first. Okay, so it becomes 2 times 3 squared, okay, because we've said in this case x is equal to 3. All right, so 2x squared in this case would mean 2 times 3 squared. Well, 3 squared is 3 times itself, which is 9. So this becomes 2 times 9, which is 18. Okay. The reason that some people get 36 as an answer is that they do 2x first. 2x would be 2 times 3, which is 6, and then square it does give you 36. But that's the wrong order. Okay, so that would be the wrong answer. All right, so that's just a quick comment on BODMAS that we did last week. The next thing we did last week was ordering, and we won't spend much time on this, but sometimes you have to order decimals, and even though we're pretty good at maths most of the time, we can trip up on this. For example, if I asked you to put those 4 numbers in order, starting with the smallest one, what would we do? Well, if you remember, the safest thing to do is to line them up in columns, okay, because then we can really see what we're doing. So notice what we are doing here. we're sticking them all in proper columns. Okay. Okay, now can you see that that's correct? What we've done is I've lined up the decimal points, and if you do that sensibly, then everything else should fall into place. Okay, all these zeros are in the units column, all these numbers here are in the tenths column, and so on. Okay, so if we want to identify the smallest number, you could start with this column. Okay, well at that level they're all the same, aren't they? They're all zeros, so that doesn't really tell us which is smallest. So now you go to this column. Which one is smallest? Well, it has to be this one, doesn't it? Because 0.18 only has 1 in the 10th column. So 0.18 is the smallest number of those 4. Is that okay, guys? Yeah? So we can kind of cross that out. That's the smallest. What's the next smallest? Well, we're still looking at this column. It's either going to be 0.2 or 0.204, isn't it? Because those have both got a 2 in the tenths column. So you look at the next column, we could stick a 0 in here. At this level, they've both got 0, so you have to go to the next column. That's got a 0, whereas that's got a 4. So it's the top number that is the smallest, if you think about it. So 0.2 is the next smallest, then it's 0.204, and then the biggest is 0.7. Okay, so don't forget that. You know, I've known very good people at maths still trip up on these things. You know, if you're not concentrating, people look at 0.18 and 0.2, for example, and try and tell me that 0.18 is bigger. Well, it's not. 0.2 is bigger because 0.2 has got 2 tenths, whereas 0.18 has only got 1 tenth. So is that clear? Yeah, brilliant. Okay, excellent. The other thing from last week then was just the adding and subtracting. Remember, again, you just got to get the columns right. You know, the adding, I'm sure you were all okay. The subtracting, when we do columns, you've just got to be careful. You know, if you have something like, as well, this is one of the more difficult ones, 704 take away 159. The first thing to do, obviously, is get it all in the right columns. That's the starting point. But then we need to be careful here with borrowing. Okay, this is one of the harder ones because there's a 0 here in the middle. But let's just have a rethink. You'd start with 4 take away 9. Okay, can we do 4 take 9? No, we can't, so we need to borrow one. Well, you try and borrow one from here, but there's a 0 there, so that's no good. So we have to borrow one from here, from the 7. So the 7 becomes a 6. And we can put a 10 in this column. Then you kind of start again. 4 take away 9, I still can't do. Can I borrow one from this column? Well, you can now because there's a 10 there, isn't there? So we borrow one of those, we cross out, there should be a 10, cross out the 10 and replace it with a 9. We've borrowed one, so we stick it in front of the 4. That's now 14 take away 9. Well, that leaves you with 5. In this column, you've got 9 take away 5, which is 4. And in this column you've got 6 take away 1. Okay, so we need to be familiar obviously with that type of stuff. Now that brings us then to the main part of today's lesson. We're going to start off with multiplying and dividing. Multiply and divide by powers of 10. Okay, by powers of 10. Well, what does that mean? Let's start off with the easier stuff, multiplying. Okay, if I have the number 32 and I want to times it by 10, putting it simply, what do I do? What's the answer? 320, basically. That's right. So we add a 0. That's the simplest way of thinking about it, isn't it? You add a 0. If I times it by 100, I would add 2 zeros. And if I times it by 1,000, 32 times 1,000 must be 32,000, mustn't it? So we add 3 zeros. Okay, so that's definitely one way of thinking about it. If you're timesing by 10 or 100 or 1,000, it's just how many zeros do I add. Okay, really though, the best way of thinking about it is not adding a 0, it's moving the decimal point. Because if we have a number like this, for example, 12.4, if I wanted to times that by 10, what's the answer this time? Good. Yeah, that's right. It is 124. So I haven't added a 0, have I? What I've actually done is I've moved the decimal point from here to here. Okay. The decimal point in the answer, if I put it after the 124, is there now, isn't it? Okay. The decimal point, in other words, if I write 1240, it started here as 12.4. When I times it by 10, it's moved to here, so it became 124. That's right, 124. Okay, so really what we should be thinking about is not adding zeros. It's actually the moving of the decimal point. If I multiplied 12.4 by 100, I could write the 12.4 that way. If I times it by 100, I move the decimal point this time 2 places, so it goes 1, 2, so it ends up after the 0, so the answer is now that. Are we okay with that? Yeah, so this is clearly the best way of thinking about timesing by 10 or 100 or 1000. It's not adding zeros really, it's about moving the decimal point. Okay, so times it by 10, I move it 1 place to the right. Timesing it by 100, I move it 2 places to the right. If I had to times it by 1000, I would move it 1, 2, 3 places to the right. Okay, so that's what we do when we're multiplying. What about when we are dividing? Well, let's think of another number. Let's start with 320 this time. If I divide that by 10, if I go, let me just make a bit more room actually. We'll write the number 320 as 320.0. Okay. If I divide that by 10, what's the answer going to be? Yes. Well done, 32.0, brilliant. Because when we divide by 10, the decimal point is moving 1 place to the left. So it goes after the 2, so it becomes 32.0. That's absolutely right. Or in fact, you could drop the 0, you could just write it as 32, couldn't you? Okay. If I go back to 320, and this time divide it by 100, what happens to the decimal point this time? Well, it's going to move 2 places, so it ends up between the 3 and the 2, so the answer is now 3.2. Alright, is that okay for everybody? Yep, fantastic. Okay, so that comes up a fair bit in maths actually, so it's just something that we need to remember. What we're going to think about now is the main part of the lesson. Okay, so this is written methods for multiplying. Okay, written methods for multiplying. Now, there are different methods, and my approach as a teacher is really just to think, well, whatever approach is best for you as a pupil is the best one for you. Clearly, I'm not going to tell you which is the best method. You can decide for yourselves which is the best method for you personally. Okay, but we need to be able to do questions such as 12.4 times 8.6. Okay, we need to confidently be able to do that question without a calculator. Okay, and that kind of question will appear on a GCSE paper, at foundation paper, sorry, at foundation level, or in even a higher level. Okay, so it is important that we are able to confidently do this. And of course, there are different methods. Well, I guess a lot of us at school are taught the column method, so you might kind of write it out this way and then try a column method. Okay, and most of us would start off in this case 6 times 4, which is 24. We write the 4 there and the 2 there. Then we do this 6 times this 2, which is 12. Add this extra 2 is 14, so you write a 4 there, carry forward a 1. And then we do this 6 times this 1, which is 6, plus this extra 1 is 7. Okay, now have any of you been taught to do it that way? Is that the way that you would have started it? Yeah, okay. Does anybody, do any of you actually not know a method for doing this? If I'd have asked you to do this a couple of minutes ago on your own, for example, would any of you, you know, it's okay owning up, isn't it? Would any of you say, well, I would have struggled to do that? A bit, okay, that's fine, no problem, because I do find a lot of students struggle with this. you see, we have got this column method, and I'll come back to it in a minute, but historically the column method causes a lot of confusion. This is my observation as a teacher. A lot of schools teach this and try and tell pupils it's the only way of doing it, or the best way of doing it. In my opinion, it is definitely not the best way of doing it, because it's full of potential mistakes. You see, when we've done the 744 bit, the next thing you would do is use this 8. Okay, and the next thing you would do is 8 times 4. Well, 8 times 4 is 32. But the issue is, where do I write the 32? Yeah, what we should do is write the 2 here and the 3 here. Okay, but lots of people forget that and stick the 2 in the wrong column. And that's when it all goes horribly wrong. Okay, so this method does work if you do it properly. It's the way I was taught at school. But what I would like to do is teach you a much, in my opinion, a much better way of doing it. Okay, if this better way is good for you, then go with it and learn it, and you know, this will be the way you probably always will do it. If you struggle with the method I'm about to tell you and you still like the old method, then that's fine. You know, just go back to the old method. But here's what we do. Okay, we really make this simple. We look at our question and we say, well, okay, here we've got 3 digits, okay, and here we've got 2 digits. So we're doing a 3-digit number multiplied by a 2-digit number. So I'm going to draw a box which is 3 by 2. Okay, 1, 2, 3 by 2. All right. We'll start with the number here, 1, 2, 4. So I'm just going to stick a 1, a 2, and a 4 there. Okay, and with this number, an 8 here and a 6 here. So nice and simple so far. The numbers always have to go in those positions, by the way. You never stick numbers here and you never stick numbers here. Okay, so they have to go in those positions. And notice as well, so far I've completely ignored the decimal point. Okay, because we come back to that at the end. What we now do is each box, you just draw a diagonal line. Okay, like I'm doing now. We just draw these diagonals. They always have to go in that direction, okay, and then at the bottom we just extend the diagonals down here. Alright, what we now do is start filling in the boxes, but this is where it becomes, I think, quite easy, because it's pretty obvious what goes in what box. This box here is going to be 4 times 8, okay, whoops, just rubbed out the red bit, there we go, put that back in. So 4 times 8 is 4 8 to 32, which I write it this way, 32. Okay, this box, the 2 drops down, the 8 moves across, so this box is 2 times 8, which is 16, and this box will be 1 times 8, which is 0, 8. So you okay so far? Yeah, has anybody seen this method before, by the way? Okay, oh brilliant, good, okay, use it already. If you use it already, that's terrific. This box down here would be 4 times 6, because this 4 drops down, this 6 moves across. They meet in this box here, don't they? So it's 4 multiplied by 6, 4 6s are 24, so we just write in 24. This box will be this 2 times this 6, okay, 2 times 6 is 12, so I stick a 12 in there. And this box will be this 1 times this 6, so it's just 6, which is 0 tens and 6 units. Alright, so nice and easy. I mean, what have we done so far? We've just drawn boxes, we've drawn a few diagonal lines, we've put some numbers in. What we now do is we add the numbers together, okay, and we add the numbers in the diagonals, and we always start at this end. So here we've only got a 4, so that drops down into the answer. In the next diagonal you've got these 3 numbers, so it's 2 plus 2 plus 2, okay, well obviously that is 6. The next diagonal is 3 plus 6 plus 1 plus 6, okay, because we have to add those together. Well, 3 plus 6 is 9, plus 1 is 10, plus 6 is 16. So we've got 16. What do we do with 16? You write the 6 here and you carry forward the 1. Okay, now we look at the next diagonal, which is these numbers added together. So you've got a 1 plus an 8 plus a 0 plus a 1. The blue one that we've drawn just counts as 1. So you've got 8 plus 1 is 9, plus another 1 is 10. 0 there, carry forward a 1. Okay, and so and here you've got 0 plus 1, which is 1. Okay, so we have our final answer, which is 10664. Okay, 10, that's right, 664. Okay, now I haven't finished the question yet because we haven't done the decimal point, have we? But what I'm hoping you're realizing by this is that so far, what's the most difficult multiplying we've done? Well, maybe it's 4 times 8 was the hardest thing we've done so far. Yeah, or 4 times 6. Really, you know, it's been pretty simple. We now go back to the decimal point, and in fact there are 3 different methods for working out where the decimal point goes. I'll go through them one at a time. Let me just try and get rid of these blue little lines here to make it a bit clearer. Yeah, that's better. One way of finding out where the decimal point goes is to put it back in the question. So if you watch the screen, I'm putting it in with a black dot now. Okay, the decimal point is here between the 12 and the 4. The decimal point goes here between the 8 and the 6. Now this first black dot can go down, 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 down. This one can go across, and can you see they meet at a point here, don't they? Yep. You could then slide that down this red line, and where does it finish? It finishes here. So that would be the answer. Okay, 106.64. Alright, so some people like that method. There's one method which I prefer, to be honest, which is really a common sense method, because if you go back to the question, this number is roughly 12, and this number is roughly, shall we say, 9? Okay, so the answer should be roughly 12 times 9. Okay, well 12 times 9 is 108, so my answer should be close to 108, and that confirms that 106.64 is therefore correct. Okay, so that's a second method, just using a bit of common sense. The third method is also quite good actually, because if you look at 12.4, how many decimal places are there in that number? It's just one, isn't it? The 0.4. Yeah, there's one. So there's one decimal place here. In 8.6, there's also one decimal place. So there's one here, there's one here. Add those together, we get 2. Therefore, there's 2 decimal places in the answer. Okay, so if you didn't know where the decimal point was, you start at the end and you go, okay, 1, 2. So it must go here. All right. So you can think about that. It doesn't matter which method you use for the decimal point. It's just, again, whichever you think personally is the easiest. Okay, so that to me is much easier than the column method. I will just cover the column method now just to kind of emphasize the difference. 12.4 times 8.6. I just think there's a bit more hard work involved here. First of all, 6 times 4 is 24, so we write that way. Then it's 6 times this 2, which is 12, plus this extra 2, which is 14. Then it's 6 times this 1, which is 6, plus the extra 1 is 7. Okay, that's as far as we got last time. Now we start with the 8, so it's 8 times this 4, which is 32, but you've got to remember that the 2 goes here, and the 3 goes up here now. Now it's 8 times 2, which is 16, plus those 3, that's 19. 9 there, carry 1. And then it's 8 times this 1, which is 8, plus the extra 1 is 9. Okay, and then we have to add that lot together. Stick a 0 in there, so we get a 4 here, a 6 here. 9 plus 7 is 16, and 9 plus 1 is 10. So you can see we get the same answer. Again, you've got different methods for working out the decimal point. So yeah, just have a play with it. What I'd like, maybe if you've got pen and paper, have a go at this one. I'll make it an easier one just to practice the box method. Okay, can we try 45 times 34? Okay, so a 2-digit number times a 2-digit number. So your box, just to get you going, your box would look like this. Okay, and just have a little go. Okay, does anyone need a bit more time? No? Okay. I'll just start to write it down myself, and then we can check. So we're writing 45 up there and 34 down the side. We then think about our diagonal lines. Okay, like that. It doesn't have to be super neat, but it needs to be, you know, neat enough for you to use the numbers properly. We'll start putting the numbers in then. This box here would have to be 5 times 3, so 15. This box here would be 4 times 3, so we just write a 12 in there. This box down here is 5 times 4, so that would be 20. And this box would be 4 times 4, which is 16. Okay, now we add them together, starting with the 0, so that's just a 0. In the next diagonal we have to do 5 plus 2, that is 7, plus 6 is 13. Remember that's a 3 there, and you carry forward the 1. Okay, next diagonal, 1 plus 2 is 3, plus that 1 is 4, plus that 1 is 5, so there's a 5 here. And in this diagonal there's only a 1, so that goes in the answer. So our final answer is 1530. Okay, did we manage to get that? You did, fantastic. Okay, brilliant. So that's really good. It's just a matter of practicing. I mean, you know how good you are at this. If you're already confident with it, then great. You don't need to practice it much more then, at least for now. Although if you're not entirely sure, it's a nice easy topic to to practice yourself, because you can set your own question. If you've got a calculator, just check your own answer. That's the simplest way of doing it. Okay. So that really, then that's good. That brings us to the end of multiplying, and what we'll do next is move on to division. Okay, so if we're taking notes, here's the title, division. All right, now let's start with this question: 522 divided by 3. Well, I guess most of us would write that down this way: 522 divided by 3. Is that how you would do it? Yep, that's certainly how most of us are taught to do it. I think this is the best method. Some people call it the bus stop method, and some people call it long division, or all sorts of names, but it doesn't matter what we call it. It's how does it work? Just to refresh our memories, how does it work? We begin by saying, okay, how many times does 3 go into 5? Well, 3 goes into 5 once. 1 3 is 3. We're trying to get to 5, so you've got a remainder of 2. Okay. Next, it would be how many times does 3 go into 22? Because we have to count this as 22 now. Okay, 3 into 22 goes 7 times, because 7 3s are 21. We're trying to get to 22, so that's a remainder 1 this time. And then final bit, how many times does 3 go into 12? Well, 3 goes into 12 exactly 4 times, and there's no remainder, so that is the exact answer. Okay, so hopefully that's okay. One for you to have a quick go at, just a quick practice: 1041 divided by 3. This just highlights one point. It's important that you can do this, because some people struggle with the beginning here. So I'll set it up. Let's just make sure we can get the right start for this one, please. Okay, we all right with that one? Let's make a start just to make sure, because as I say, some people just struggle a bit with the beginning here, because the start is slightly different. We started the last one, how many times does 3 go into 5, didn't we? And 3 into 5, well, 3 does go into 5 at least once, so that was an easy start. This time it's how many times does 3 go into 1? Well, 3 does not go into 1. So a lot of schools teach you to put a 0 here. You don't need to. We just say, okay, how many times does 3 go into 1? It doesn't. Therefore, we'll just treat this as 10. We'll just go to 10 now. We'll say how many times does 3 go into 10? This is the simplest way of thinking about it. So, okay, how many times does 3 go into 10? Well, 3 times 3 is 9, isn't it? So it goes in 3 times, and we've got a remainder 1, so that goes in front of the 4. Now we keep going. How many times does 3 go into 14? Well, 3, 6, 9, 12. 4 3s are 12. You're trying to get to 14, so you have a remainder 2. And then how many times does 3 go into 21? 3 times 7. All right. So is that okay, guys? Were you okay with the beginning of that one? Yeah, brilliant. Okay, just some people trip up with that, so that's good. Now, what happens though if we get some kind of remainder? So let's have a think about this one. 326 divided by 4. Just set it up that way. If you think you can have a go, because this won't go in exactly, okay? You're not going to get an exact answer. So the issue this time is, what do we do when we get a remainder? Alright, shall we go through it? Good. The start then is, how many times does 4 go into 3? Well, okay, 4 does not go into 3, so we can just think, keep it simple. Okay, we'll treat this now as 32. How many times does 4 go into 32? Well, 4 8s are 32, aren't they? So it goes in exactly 8 times. 4 8s are 32. There's no remainder. But we haven't finished yet, so we have to say, okay, how many times does 4 go into 6? It goes in once. 1 4 is 4, so we've got a remainder 2. Okay. What do we do with the remainder 2? Well, if you go back to the number 326, we can write it as 326.0, can't we? In fact, you can have as many zeros here as you want. And the remainder 2 just has to carry forward. So the remainder 2 goes here, okay, in front of the 0, in front of that first 0. But you need to remember, because we put a decimal point here in the question, we've got to put it in the same place in the answer. And then you just keep going. So it's now, how many times does 4 go into 20? Well, 4 times 5 is 20, and there's no remainder. So that's the answer, 81.5, okay? Did anyone manage to get that anyway? Did you get that on your own? You did. Okay, excellent. So that's, again, it's just practice, and again, you know how good you are at these things. Sometimes you've got to keep going quite a long way though with the remainders, and then you end up with quite a long decimal number. And we'll do another one of those actually shortly. Here's a question for you then that we sometimes don't think about, and this could be more of a GCSE type question. If you were asked to do that without a calculator, okay, 2,420 divided by 18 without a calculator, it looks a bit more difficult, doesn't it? Because not many of us know our 18 times table particularly well. So you've kind of got a choice here. You could do it the way that we always do it. You could say, well, I always use the bus stop method, I'll just persevere with it. And you'd have to start with, how many times does 18 go into 24? Yeah, well, it goes in once. The remainder this time would be 6, and then 18 into 62, and then just keep going. Okay, so you could do it that way, but if the numbers were particularly awkward, that becomes quite difficult. Okay, 18's not too difficult. If it was 38 or 48, you know, we may have a much more difficult question. So can anyone think of a way of simplifying our question so that it becomes easier? Divide it by 10. Well, actually, the dividing method is actually, in a way, the dividing method is a good method. If we divided this by 10, though, if we divided both numbers by 10, if that's what you mean, we'd have a problem because we'd end up with 242 divided by 1.8 because you'd have to divide both numbers by 10. But your idea is a good one, because if this divided by sign here, we could rewrite the question this way: 2,420 divided by 18. Okay, that's just another way of writing exactly the same question. But the advantage of writing it this way is that we're now thinking, hang on a minute, this looks like a fraction, doesn't it? It looks like it is a fraction. It's just a top-heavy or improper fraction. And if we get fractions, if we had a really simple one like 4/6, it reminds us that we can actually simplify it. Okay, are you familiar with simplifying fractions? Yeah, because you look at the 4 and you look at the 6 and you say, is there a number that goes into both? Okay, well 2 goes into both. So I could divide both these numbers by 2. Okay, 4 divided by 2 is 2. Obviously 6 divided by 2 is 3. So 4/6 is the same as 2/3. That's called simplifying. Well, we could do that with our question here. We could say to ourselves, okay, what goes into 2,420 that also goes into 18? Well, I suppose the obvious one is 2, because they're both even numbers. So divide the top number by 2, and we get that. Divide 18 by 2, and we get that, don't we? Okay. Now remember, this is an important bit. These are equivalent fractions. Therefore, they have the same value. Therefore, they are the same question. You know, the answer to this question is the same as the answer to this question. Okay, because it will have the same value. So we've changed the question, and we've actually made it a little bit easier, because what we've now got to do is 1,210 divided by 9. Okay, and that just becomes an easier question because we're dividing by 9 instead of dividing by 18, aren't we? Okay, so you just go, okay, how many times does 9 go into 12? 1 remainder 3. How many times does 9 go into 31? Well, 9, 18, 27 goes in 3 times. That gets you to 27. Remainder 4. 9 into 40. 9, 18, 27, 36. So 4 times will get me to 36. I've got a remainder 4. What do I do with remainder 4? Well, it's like the previous question, isn't it? We stick it here, and you keep going. 9 into 40, 4 remainder 4, 9 into 40, 4 remainder 4, and you can see now these 4s would actually go on forever. Okay? Was that alright, guys? Could you follow that? Yeah. So what the thing to remember from that example is sometimes you get a question like this one that looks tough. Okay, that's a tough division question. So a little bit of common sense. Just think to yourself, hang on a minute, can I make it into an easier question? And then just solve the easier question. All right, we have to do that a lot in maths, especially when we get into GCSE work. The other question you get asked where we have to use division is this question here. Okay, we need to be able to do this at top level, Key Stage 3, and also GCSE level. You need to be able to convert a fraction into a decimal. Alright, and it may ask you for the answer to 3 decimal places, let's say. So you're asked to convert 1/7 into a decimal without a calculator. How do we do it? Has anyone got any ideas? What would we do? Or what would we try to do? Okay, well, the secret to thinking about this question is to think about this fraction, 1/7. What does 1/7 actually mean? Decimals tend to have 2 meanings, okay? In one way, it means 1 out of 7, doesn't it? Okay, if we were going to shade 1/7 of something, we would shade 1 out of every 7. So we can think of 1/7 as 1 out of every 7, but it also means 1 divided by 7. Okay, this line here is the division line. Okay, so in fact I haven't mentioned this before, but some people don't realize this. You know, that's the division symbol. Do you know why it's the division symbol? It's because what it means is one number divided by another number. This is actually a fraction. The division symbol itself is a fraction. And so we're reminded that 1/7 actually means 1 divided by 7. And that's how you would convert it into a decimal, because we treat it as 1 divided by 7. Okay? So let's see if you can have a go at this. You're going to have to we know it's going to be a decimal, so we may as well put some zeros in here already. So just have a little go. If you've got pen and paper there, have a go at this one, and see if you can come out with the decimal answer. Remember, to 3 decimal places, okay? Okay, let's go through it, guys, because I think time's running out a little bit as well here. So let's begin. How many times does 7 go into 1? Well, it doesn't. So we can write the 0 up here. Decimal point goes here. The 1 kind of carries forward, okay? So we can treat this now as 10. So the next question is, how many times does 7 go into 10? Well, 7 goes into 10 once, remainder 3. Now it's, how many times does 7 go into 30? Well, 4 7 to 28, remainder 2. 7's into 20. Well, that would be 2 7s of 14, remainder 6. So we need to keep going here. There's a 6 here to write in. 7 into 60. Well, 7 8s of 56, so that's going to be an 8. But we can stop there because we only wanted the answer to 3 decimal places. We've got 0.1428. What would that be to 3 decimal places? Well, there's the 3 decimal places. This number here tells us what to do with the 142. In fact, because this is an 8, it tells you to round up this 2, so it would be 0.143 to 3 decimal places. So is that all right? Yeah. So this is really as far as we need to go with division. I know the basic division you seem to be fine with. This kind of stuff, no problem. You just need to know, or to make sure that we probably remember 2 things here. One is, when you get a harder question, look to see if you can simplify it. Just makes life easier. And if you get a decimal, if you get a fraction rather, and they ask you to convert it into a decimal, then we use our long division skills, okay? And if you manage to follow that last one, then that's great. You can do all of them. All right, so we're virtually there. There was one just final thing I wanted to mention, because sometimes we get this question. This will only take a minute. They sometimes tell you in an exam, if something like 87 times 231 is this answer, okay? So they say if that is correct, which it is, find 8.7 times 2.31. Okay, this question crops up at GCSE level and at Key Stage 3 sometimes. So it's an unusual one, because they start off by telling you the answer to a question. What they're really saying is that use that answer to answer this one. Okay, so you think, well, okay, hang on, how's that going to help me? Well, there are 2 ways of thinking about this. Remember, there's the common sense approach. This number is roughly 9. This number is roughly 2. 9 times 2 is 18. So the answer must be close to 18. It's going to have to contain the same numbers here. If it's close to 18, it must be 20. So I'll stick a decimal point in there. And that is the correct answer. Okay, do you see how we did that? Just with a bit of common sense. The other way of doing it, which some people suggest, is you just compare the numbers. This is 87, well, and this one is 8.7. So here, this number's 10 times less. So the answer should be 10 times less. So if we put we move the decimal point to here already. Okay. and then you look at that number and you look at this number, well, this number is 100 times less, so we have to move the decimal point another 2 places, so it ends up in there. Alright, so just two different ways of thinking about the same problem. Alright, so I think we can finish there, guys. So thank you for joining us today. I hope that was helpful. What do we get out of today? Some of you, I guess, may have just, you know, maybe thinking about a new method for multiplying. If you struggle with the column method a bit, really have a go at this. I call it the box method. The box method is brilliant for multiplying. It works with everything. Think about the method for putting the decimal point in at the end. And again, that makes life simple. So see how you get on with that. And those of you who do it already, just keep practicing it. Okay. All right. So thank you very much. It's probably time to say goodbye. So thanks for joining us, and I look forward to speaking to you next time. Okay, guys. Bye. Thank you. Thanks a lot. Bye-bye. Bye now.